Next topic on graphing linear inequalities. Let's just take the time to just go through and just review what it was like to be or what the characteristics of inequalities, right? So we have this inequality here: 3x minus 6 is the sign is greater than 21, and if you remember, these are the four inequality signs: is greater than, less than, okay, and then you had a greater than or equal to, greater than or equal to, and then less than or equal to. So these are the four symbols, and if you see any of these four symbols, that's how you know that you're dealing with an inequality. So we have 3x minus 6 is greater than 21, and it's the same exact way as if you were solving an equation meaning that it has an equal sign. And so we would start by isolating this x over here. So we're not going to touch this. Okay, instead we're going to add 6 to both sides, and we're left with 3x is greater than 27, and then we're going to continue solving for x by dividing both sides. Dividing both sides by 3, and these cancel out. By 3 divided by 3 is 1, so x is greater than 27 over 3, which can be simplified to be 9. Okay, now this does say to graph it, and we don't have an actual graph like this, so that's not the type of graph that we're going to be using here. Instead, we're going to be using something called, like, it looks like a number line. Okay, the way that I graph it is that wherever number we have here, that's the one that I place right in the middle. So I'm going to start at 9. If you move to the right, okay, we're going to be going 10, 11, 12, and then as you move to the left, okay, we're going to be decreasing. 6, 5, right? So this sign here is a greater than. So because it does not have the or equal to, this is going to be an open circle. Okay, looks just like this. And since this is a greater than, we're looking at all the numbers that are greater than 9. So that's going to be going to the right. So we're going to shade right. Okay, so we're going to go over here to 9, put an open circle, and we're going to shade to the right, just like this. Okay, and that's how you graph. Now this means that every number here is a solution. So if we were to randomly choose a number, let's say we chose this 11 here. Okay, so I'm going to take this 11 and I'm going to plug it inside this inequality. So let's try 3 times, now instead of the x, I'm going to write 11, right? The 11 is going right there. 3 times 11 minus 6 is greater than 21. This is 33 minus 6 is greater than 21. If we simplify this, this would be 27, and then you ask yourselves, is 27 greater than 21? Definitely true. Okay, if however we were to choose a different number, let's say that we chose 6, now notice that 6 is not, it's on the opposite side of where we were shading, right? It's here. If we were to substitute the 6 in instead of the 11, it would change our answer. We get 3 times 6 minus 6 is greater than 21. Okay, the original inequality being this, and all we did was just substitute the x for 6, and we had 18 minus 6 is greater than 21. 18 minus 6 we know is 12, and is 12 greater than 21? It's not true. This is false. So what this tells us is that any number that is in the shaded area of this line here, if you were to plug it inside the original, it would be a true statement. Okay, if we were to plug in 9, now notice that this is an open circle. Okay, if we were to plug in a 9, let's see what would have happened. Okay, so I'm gonna go ahead and just erase this piece, and we're gonna substitute in a 9. So we had the original was 3x minus 6 greater than 21. I'm plugging in the number that I started off with, right? So 3 times 9 minus 6 is greater than 21. This is 27 minus 6 greater than 21. This right here is 21 greater than 21. Now notice that both sides are the same number, but is this true? Is 21 greater than 21? Is this false? Not true. Okay, if however it had this bar on the bottom, if it was greater than or equal to, then that would have been true, but since we don't have that, it's just false. All right. Okay, so let's move on to graphing one of them. All right, so it says if we want to sketch the graph of the linear inequality, it looks like it's in slope-intercept form, okay, which is perfect for graphing. That's the same thing as y equals mx plus b, only in this case we're not dealing with an equal sign, we're dealing with an inequality sign. That inequality sign is a greater than or equal to. All right, so the way that we're going to graph this, I'm just going to write this over, is we need to identify two things. The first thing is you need to have your slope, and we need to know the y-intercept. All right, so the slope is always found next to that's always the number that's next to this x here. All right, and I'm going to write it as a fraction. So this slope is -2/1, okay? And our y-intercept, that's this one right here, this will be our y-intercept, this will be our slope. Now when you're graphing it, the y-intercept is exactly what it sounds like. It's literally where the graph intercepts or touches or crosses the y-axis, this being the y-axis here, right? So we're going to go to +5 as our starting point, 1, 2, 3, 4, 5. So the graph should cross right here. And then to graph these points now, we take a look at this. Okay, and I'm going to rewrite this on the bottom here, -2/1. If you have a negative sign, okay, this just means that you're going to go down, or we're going to fall. So we're going to fall down first, but you always move to the right. So move to the right. So we're going to be going down by 1. I'm sorry, not down by 1. We're going to be going down by 2. Okay, that's what the negative means. We're going to be going down by 2, and we're always moving to the right, unless we run out of space. So from here, we're going to go down by 2, right 1. Down by 2, right 1. Down by 2, right 1. And just keep repeating the pattern until you run out of space. Down by 2, right 1. Okay, down by 2, I'm off the screen. Okay, if I go the opposite way, up 2, to the left 1, I'm out of space. So this is where I'm going to stop. Now, normally we just draw a straight line, but being that this is an equality, we can't do that. So if we have a greater than or equal to, or less than or equal to, this is a solid line. The way that I remember that is because if it has a solid line underneath the inequality sign, that just helps me remember, okay, I'm dealing with a solid line. All right. Also, we're dealing with a greater than sign. That's this guy right here. So if it's greater than, we're going to shade above. Okay, think about the word greater, greater being above, so we're going to be shading above. So this is going to be a solid line. Okay, I'm going to try to make a solid line here. It's not going to be all that great. Okay, not the best solid line, but you get the idea. And we're going to be shading above. Now sometimes I know shading above can be a little challenging, so what I always do is I always put like a little guy here, and I think that I always put him at the top, and then I move him to where I believe the line starts. So I'll put him right here. And if he's walking down the stairs, right, I always think this is like a stairs. He's walking down the stairs, where would his above be? Would he be here or here? Well, if he's walking down, right, because his line is going down, his above would be here. And so this is going to be where all our solutions are. And what that means is, I'm going to erase this piece. What that means is that if you choose any point inside here, let's say I choose a random point, let's put this one right here. Okay, what point is this? This is 4, 5, so 4, 5, right? This is your x and your y. I'm going to take this random point, okay, that's inside of this shaded area. I'm going to take this and I'm going to plug it in to the original. So the original inequality was -2x plus 5. And we're going to substitute it. Okay, remember this is your x, this is your y. So y was 5, -2 parentheses, this 4, because the 4 was x, plus 5, and then we're going to evaluate it. So 5 is greater than or equal to, this is what, -8 plus 5. And if we were to continue that, we get 5 is greater than or equal to -3. So is 5 greater than or equal to -3? Well, any positive number, okay, so positive is going to be greater than a negative number, so this is true. meaning that every single point here, this is a solution, this is a solution, this is a solution, every point inside of here is a solution. There's so many that we just shaded in, and we call it a solution set. All right, so I'm going to pause here, and I'll continue with another video.